DNA from a single tooth just shattered everything we thought we knew about the last Neanderthal. And it's not because it proves they were smarter or stronger or more like us than we thought, but because it tells the opposite story. One so quiet, so bleak, and so unexpected that it flips the entire Neanderthal extinction theory on its head. This isn't the tale of some epic last stand. It's about a forgotten group, stranded for tens of thousands of years in isolation, slowly collapsing under their own genetic weight. And one man's tooth, discovered in a French cave, just revealed the full picture. Today, we're diving into what that tooth actually shows, because it doesn't just rewrite Neanderthal history, it rewrites our own. Let's start with the cave. A narrow limestone pocket tucked deep in the Rhône Valley of southern France. It's called Grotte Mandrin, and at first glance, it doesn't look like anything special. But it turns out this one cave held two timelines inside it. One belonged to us, modern humans, the other to Neanderthals. And they didn't just live in the same region. They used the exact same cave, sometimes just a few thousand years apart. Think about that. Two entirely different species of human, separated by evolutionary time, walking the same trail, entering the same shelter, maybe even leaving footprints in the same soil, but they never met, at least not here, not in this cave. In 2015, archaeologists digging through Grotte Mandrin uncovered a fragment of a jawbone and a few teeth. Nothing flashy, no spears, no cave art, just tiny fragments of bone and enamel. But hidden inside one of those molars was something priceless, ancient DNA. And thanks to newer, less destructive techniques, scientists were able to extract and sequence it without destroying the tooth itself. The key was the cementum, the thin layer around the root of the tooth, which preserves original DNA better than almost any other part of the body. Think of it like a biological time capsule, one that sat untouched for over 40,000 years. The individual the tooth belonged to was male, an adult Neanderthal, and the researchers nicknamed him Thorin. Now here's where things get strange. When they mapped out Thorin's DNA, when they compared it to other known Neanderthals across Europe and Asia, they expected him to fit into the big picture. He didn't. Thorin didn't cluster with the other late Neanderthals. His lineage had broken off from the rest of the Neanderthal world more than 100,000 years earlier. And then, nothing. No sign of mixing, no influx of new genes. For over 50,000 years, his group stayed completely isolated. That's not just rare. That's unheard of. But here's the kicker. Grotte Mandrin wasn't isolated. It's not some remote cave in the middle of nowhere. In fact, we know for a fact that modern humans used this exact same cave about 54,000 years ago, 10,000 years before Thorin lived there. And yet, Thorin's DNA shows zero trace of modern human ancestry. No gene flow, no interbreeding, no contact, even though they were literally living in the same place. So what happened? The answer might be even more uncomfortable than we want to admit. It looks like Thorin's group wasn't just isolated. They were stuck. Socially, geographically, genetically. This group had been cut off from the rest of the world for tens of thousands of years, and the consequences of that isolation show up everywhere in his genome. Thorin's DNA has extremely high homozygosity, in plain terms, inbreeding. His parents were likely related, maybe as closely as half-siblings or cousins, and they weren't the only ones. His entire group showed signs of long-term, multi-generational inbreeding. We're talking about a population that might have numbered in the dozens, maybe even less. A tribe so small, so disconnected, that their gene pool had collapsed into itself. This isn't the Neanderthal story we were told in school. The old model said they were wiped out by Homo sapiens in some kind of slow-motion war, that our ancestors swept across Europe like an invading army, out-competing or out-killing them. But that's not what Thorin's tooth shows, because Homo sapiens were already there. And they didn't attack, they just didn't interact. To understand why this is such a huge deal, we need to rewind. For decades, scientists debated how Neanderthals disappeared. Some blamed climate, others blamed competition, others thought interbreeding diluted their genes. But a new generation of genome data started painting a different picture. First, the Altai Neanderthal, a woman from Siberia who lived about 120,000 years ago. Her genome showed extremely close inbreeding. Her parents were as related as half-siblings. Then came Vindija, around 50,000 years ago. This Neanderthal's DNA had fewer signs of inbreeding, but still pointed to a small population. But all of these had something in common. They came from remote regions. Thorin was different. He lived in Western Europe near the Rhone corridor, surrounded by habitable land and species-rich ecosystems. This shouldn't have been an isolated place, and yet Thorin's group was more genetically cut off than almost any Neanderthal ever studied. So why does this matter? Because it changes the way we understand extinction. Neanderthals didn't just vanish because they were outcompeted. They vanished because they were already falling apart. They weren't a unified species anymore. By the end, they had fractured into isolated groups, tiny genetic islands drifting apart. And when the climate started shifting, when ice age pulses reshaped the landscape, when prey populations moved, when competition increased, those little groups couldn't adapt fast enough. Thorin's people didn't need to be wiped out. They were already fading. And that brings us to something even more haunting. If Homo sapiens really did live nearby, why didn't they help? There's a theory in anthropology called the social boundary hypothesis. It suggests that even when two human groups live in close proximity, cultural, linguistic, or social differences can form invisible walls. It's not about whether they could have interbred. It's about whether they wanted to. And in Thorin's case, all signs point to no. Modern humans and his Neanderthal group might have avoided each other completely. Or worse, ignored each other. This isn't just a scientific revelation. It's an emotional one, because it reframes the extinction of Neanderthals not as a dramatic battle, but as a slow-motion abandonment. A group of humans slowly collapsing in on themselves, while another group watched and walked away. And here's where things get even darker. If Thorin's lineage was isolated for 50,000 years, that means they were already cut off before Homo sapiens ever entered Europe. So their decline wasn't triggered by us. It had already begun. And that's the real truth the DNA reveals. Not a final battle, not a climatic disaster, not a sudden extinction, but a drawn-out unraveling, hidden in the genome of one man. One tooth, one cave, one final message written in ancient code, and we're only just starting to understand what it means. The obvious question is, how do we even know all this from a single tooth? The answer isn't magic. It's molecular archaeology, a blend of genetics, chemistry, and mind-blowing modern tech that lets us pull full genomes from fragments smaller than a fingernail. In Thorin's case, the breakthrough came from the cementum, that outer shell of the tooth root. It's dense, durable, and happens to be one of the best places to find ancient DNA. Scientists used a technique that avoids grinding up the tooth entirely. Instead, they apply a gentle chemical wash to the cementum layer, extract whatever DNA is preserved inside, and then sequence it using high-powered machines that can read millions of fragments at once. These fragments aren't in order. They're chopped up, damaged, and scattered like pieces of an ancient jigsaw puzzle. But by comparing them to other known genomes, aligning overlapping sequences, and filtering out contamination, researchers can reconstruct something close to the original genetic code of the person who lived and died tens of thousands of years ago. But they don't stop there. To validate that the DNA is truly ancient, they check for telltale signs, chemical damage patterns caused by time and temperature, short fragment length since ancient DNA breaks down, specific base substitutions that only occur in degraded samples. And once they're confident the DNA is authentic, they run it through population genetic models. This is where things get wild. Thorin's genome wasn't just compared to other Neanderthals. It was compared to early modern humans, Denisovans, and even the genomes of living people today. And when scientists did that, Thorin stood out like a ghost. He didn't match the Neanderthals who gave DNA to modern humans. He didn't match the Denisovans from Siberia. He didn't even match the Neanderthals living nearby. His group had split off the evolutionary tree long ago and never rejoined, which means most of us, carrying our 1 to 2% Neanderthal DNA, are not descended from people like Thorin. We're descended from other Neanderthal groups, ones that did mix with Homo sapiens. Thorin's people? They left nothing. And that brings up a brutal reality. Extinction isn't always loud. Sometimes it happens in silence. Imagine this. A small band of Neanderthals clings to life in the French countryside. Each generation, the pool of potential mates shrinks. Children are born with inherited weaknesses, not because of some curse, but because the group is just too small. No new genes, no outsiders, no rescue, just cousins marrying cousins over and over again. And all around them, change, new tools, new species, new climates, but they're trapped in their habits, in their networks, in their DNA. We used to think Neanderthals were dumb, that they couldn't keep up with modern humans. But that was always a lie. They made stone tools, buried their dead, used fire, hunted big game. They even painted cave walls long before Homo sapiens ever arrived. But intelligence wasn't enough, because evolution isn't fair. You can be clever, you can be strong, but if your tribe shrinks below a certain threshold, it's over. This is called the Ali effect. It's a concept in population biology that says once a group gets too small, it can't sustain itself, not just genetically, but socially. There aren't enough partners, not enough knowledge transfer, not enough resilience when something goes wrong. One bad winter, one outbreak, one bad hunt, and you lose the elders, then the hunters, then the future. Thorin's genome is a case study in the Ali effect. His inbreeding wasn't a fluke, it was a symptom of demographic collapse, of geographic isolation, of extinction from the inside out. And this wasn't just happening to his group. Other Neanderthal genomes tell similar stories. And here's what really changes everything: this fragmentation, this splintering of the Neanderthal population. It didn't happen after Homo sapiens arrived. It happened before. That's the part nobody expected. We assumed Neanderthals were holding strong until we showed up, that they were a unified population and we disrupted the balance. But the DNA doesn't support that. By the time Homo sapiens even entered the picture, Neanderthals were already in pieces, broken into pockets, like islands in a shrinking sea. And when the climate changed, again, those islands started sinking. Between 50,000 and 40,000 years ago, Europe went through a period of intense climate instability. Rapid temperature swings, ecosystem shifts, rainfall patterns changed, forests turned to tundra, rivers dried up. And when your population is already tiny, already fragile, even small environmental shocks can become death sentences. Now add in one more pressure: us, not as an invading army, but as quiet, efficient competitors. We moved fast, we built stronger social networks, we traded tools, ideas, resources. We adapted to more environments, exploited more food sources. And when our paths crossed with Neanderthals, we didn't always fight, but we almost always won. Not because we were better, but because we had numbers, because we had connections, because we weren't alone. And Thorin's people were. By the time his tribe made their last stand in Grotta Mandrin, the writing was already on the wall. Modern humans were in the region. Climates were shifting again. And the inbreeding in his genome showed that his world was getting smaller and smaller and smaller, until finally it ended. No war, no grand finale. Just silence, one of the last Neanderthal lineages gone. Not because of violence, but because of isolation. And the DNA proves it. The story of human and Neanderthal interaction is usually told in one chapter. We show up in Europe around 45,000 years ago. They disappear a few thousand years later. End of story. But that version was never quite right. And now, new discoveries are stretching the timeline far beyond what anyone expected. In 2025, a research team announced something shocking. They had reanalyzed a child's skull from Skull Cave, Israel, first found almost a century ago. The child lived around 140,000 years ago, and their features were weird, not fully Neanderthal, not fully Homo sapiens, something in between, long, low skull shape like a Neanderthal, but small chin, reduced brow ridges, and more rounded brain case, traits seen in early modern humans. The team ran CT scans, morphometric analysis, compared it to hundreds of fossils, and their conclusion? This wasn't just a child with mixed features. It might have been a hybrid, a child with one Neanderthal parent and one Homo sapiens. If true, it would rewrite the start of our relationship by nearly 100,000 years, because that would mean we were interbreeding long before we ever made it to Europe. It would mean the Middle East wasn't just a migration corridor, it was a meeting ground. Now, to be clear, this claim is controversial. It's based on morphology, not DNA. No genome has been recovered yet from that skull. But it adds weight to something many scientists have suspected. that our species didn't just bump into Neanderthals once or twice. We overlapped, interacted again and again, over thousands of years, across continents, and yet Thorin's genome tells a completely different story, because he lived much later, in a region where modern humans had already come and gone, and he still shows zero evidence of human contact, no interbreeding, no gene flow, no cultural borrowing, just silence. So how is that possible? How can we have Neanderthal-human hybrids 140,000 years ago, but a pure Neanderthal 50,000 years ago, living in the same region? The answer is something we've hinted at before: population structure. Neanderthals weren't one giant tribe. They weren't a single pan-European population. They were fractured, fragmented. Some groups mixed with us, others didn't. Some vanished early, others lasted longer. Think of it like a shattered mirror. Each shard reflects a different part of the story. And Thorin's shard? It's the loneliest one of all, because his group didn't just avoid modern humans. They avoided other Neanderthals too. That's right. Thorin's genome doesn't show close ties to Vindija, Altai, or Chagirskaya groups. In fact, his lineage likely split from the rest of Neanderthals over 100,000 years ago, and never reconnected. Not with Homo sapiens, not with neighboring tribes. No visitors, no marriages, no alliances. They were an island, a closed system, and while that kind of isolation might protect against outside threats, it comes at a cost. No new genes means no new immune defenses. No new mates means rising inbreeding. No contact means no trade, no tech sharing, no help when things go wrong. You'd think survival would force groups together, but the opposite often happens. In times of stress, groups pull inward, circle the wagons, protect their own, even if it kills them. And that might be exactly what happened to Thorin's people, because while the world was changing around them, new species arriving, rivers shifting, forests thinning, they stayed the same. Same tools, same behaviors, same genes. Until eventually, there was no one left to carry them forward. It's tragic, but it also raises a bigger question. Why did some Neanderthals interbreed with us, and others didn't? What was different? Was it timing, geography, personality? Maybe all of the above. Some Neanderthal groups may have been more open, more mobile, more curious. Others, like Thorin's, may have been insular by necessity, too small to move, too inbred to adapt, too isolated to change course. Or maybe the problem wasn't them. Maybe it was us, because even though we think of ourselves as social creatures, we haven't always been kind to outsiders. The history of Homo sapiens is full of boundaries, tribalism, distrust, violence, and it's entirely possible that when our ancestors saw Neanderthals, they didn't see cousins, they saw threats. So maybe the reason Thorin's people didn't mix with modern humans was because modern humans didn't let them. We'll never know the exact answer, but the pattern is clear. By the time we started mixing in places like Croatia or the Levant, groups like Thorin's were already cut off, and that's what makes this tooth so important. It doesn't just tell us about one man, it tells us about a vanishing world. A world where Neanderthals didn't all go out with a bang. Some just faded, quietly, into the dirt. So let's put all the pieces together. When scientists first looked at Neanderthals, they saw a simple story. A species that vanished, replaced by us. Maybe in war, maybe through breeding, maybe by accident, but either way, gone. But DNA doesn't lie, and what it shows now is something much more human and much more haunting. By the end, Neanderthals weren't united. They weren't thriving. They weren't competing in some grand showdown against Homo sapiens. They were shrinking, splintering, breaking apart. Each group was like a flickering campfire, burning alone in the dark. Some still had strength, big enough to survive a few generations longer. Others, like Thorin's people, were already on the edge, cut off, inbred, stranded. And the real tragedy? They weren't wiped out in a single cataclysm. There was no meteor, no genocide, no dramatic final stand. They just slipped away. Because the truth about extinction is that it doesn't always scream. Sometimes it whispers. Sometimes it's quiet footfalls leaving no mark. Sometimes it's a tribe that doesn't have enough children, or one that can't survive the winter, or one that just stops. Thorin was one of them, and in his DNA, we don't find failure. We find fragility, a reminder that survival is never guaranteed, that even the strongest, smartest, most adapted species can lose the race if their world gets too small, too disconnected, too alone. And that makes his tooth, this tiny fossil found in a forgotten cave in France, more than just an artifact. It's a eulogy for a species that once spread across Europe and Asia, that hunted mammoths, that made fire, that survived ice ages, and whose final message to the world was hidden in a fragment of enamel until now. But this story doesn't just belong to the past, because we still carry their DNA in our skin, our hair, our immune systems. Neanderthal genes shape how we respond to viruses, how we heal, even how we dream. Every time you look in the mirror, a piece of them looks back. But that legacy only comes from the groups that survived long enough to mix with us. Not Thorin. His lineage left no mark, no descendants, no future, except for this story. And maybe that's enough, because if there's one lesson this tooth teaches us, it's that we're not as different as we like to think. So next time you hear someone talk about Neanderthals like they were brutish, dumb, or doomed, remember Thorin, not as a failure, but as a reminder of how easy it is to vanish, even with fire in your hands, and how fragile a species can be when no one comes to help. Thanks for watching. If you want more forgotten discoveries and real mysteries from deep history, subscribe and turn on notifications. Until next time, keep questioning everything.